Hi, and welcome to a Penji video on compound truth statements. So the first thing I'd like you to do is just watch the program execute. And I'm just going to step by step go through this program. And as we go through it, I'd like you to, and I'm going to pause it for a second here, I'd like you to think about what could replace the question marks to make the program that you're going to see play out at the bottom here happen. And as you can see, our penguin starts at 3-4 and travels down this road to exactly this point and drops fish during the entire time. Since we're trying to figure out Boolean expression for the while loop, we can use a question that I've told you you should ask anytime you're trying to figure out what your while loop condition should be. And ask yourself, as you look at where the penguin ended, what is different about this cell? If you look at every cell in the penguin's journey, there is something that immediately changed right here, right? And it's that there is not a rock and there's not a cube. As we go through this, you can see there is a cube on the left, a rock on the right, and you may have already figured out what goes in the while loop. The while loop is while Penji is cube left or Penji is rock right. And for a or statement to be true, at least one of the conditions must be true. So throughout the penguin's journey, one of these two is always true. How do we know it's true? Because for the penguin to be able to move forward, drop a fish, and waddle, this condition must be true. And so what we're going to try to do is come to understand what a truth table is. And a truth table is really just a way of breaking down a compound statement. What I mean by a compound statement is that there's more than one thing here. There's is cube left, we have an or, and we have the other thing, is rock right. What we want to know is what makes this compound thing true. And we know that it's true anytime that the penguin moved. So anytime that there is a cube on the left, anytime that that was true, the entire statement was true. It didn't matter. Right here, is rock right is false. It doesn't matter though, because is left is true. Okay, so as long as either is cube left or is rock right, represented by the blue highlights, the other case is when there is cube left is false, like this, in all the blue cases, but is rock right is true. And again, we know the full compound statement is true because the penguin would move on during that situation. So how do we know that what I just said is true? For an or statement to be true, at least one of the conditions must be true. Well, think back to how loops work. Lines 3 and 4 are inside our loop, while Penji is cube left or Penji is rock right. So as long as whatever is here is true, these commands will execute, drop, waddle, drop, waddle. Well, that's what happens during this whole row here. Either is cube left is true, highlighted in red, or highlighted in blue, is rock right is true. One or the other is true. Red case, blue, red, blue. Cube, rock, rock, cube, right? So the takeaway that we can get is for an or statement, one of the two must be true for the whole thing to be true. And you can represent this in a truth table, which you're going to experience probably at some point in your math classes. A truth table is just a way for us to break down this compound situation. It's compound because we have two things. We have cube left or rock right. We know it's true when is cube left is true, is rock right is false. And we know that because in this situation, the penguin will drop a fish and will waddle. And if you flip it around, in the blue situation, we also know that the compound statement is going to be true because in the blue situation, what happens? The penguin is right here. There is a rock on the right. Is cube left is false, but the penguin drops and waddles. So what if we make one small change to the map? I deleted the rock that's right there. Can you figure out where our penguin, Penji, is going to stop? let's step through it and see. Is cube left is true? So we're going to drop and waddle. Can you figure out where it's going to end? It's going to end right here. Is cube left is false. Is rock right is false. You need one of them, at least one of them, to be true for the whole condition to be true. Right, and our loop is now over it. And on the bottom here, you can see a truth table for when cube left is true, rock right is false, or we have false and true. In both of those cases, the whole or statement is true. Now, what about this? What if both conditions are true? What if is cube left is true, is rock right is true? Do you think the entire statement will end up being true or false? There's an easy way to find out. We're going to check it out with the program. We can answer that question right now with this map. You can see that is cube left is going to be true, is rock right is going to be true, and if the penguin drops and waddles here, then we know that if both conditions are true, the whole or statement is true. And let's see what happens when we run this code. And yes, it is true. So here's our final loop statement. For a or statement to be true, at least one of the conditions must be true. It's okay if both are true, right? So it could be a true false, a false true, or true true, and the entire thing will be true, right? So now let's move on and just look at a common syntax error. Up on the screen here is a common error that people who are first writing or statements often make. Can you see an error? And I'll give you a hint, it's in line 2. Give you a few more seconds. If you want another hint, it's towards the end of line 2. And the problem is that you have to repeat Penji here. A lot of people, when they're first doing this stuff, assume that Python would know that if you did Penji is safe, that here you would mean Penji is water. And that's not true at all. You could have many penguins, and how does Python know which penguin is using the is water method? Okay, so don't forget when you use an or statement to repeat Penji, or if you made your penguin's name Pam, that you repeat Pam here. So take a peek at an upcoming map. Can you figure out what code you should write? And I'll show you what the program actually does if you run it. What code would you write? And now the program is over. Here you go. While Penji is fish left or Penji is rock left, Penji.waddle. Either there's a fish or a rock, and only one of them has to be true, and you're done. All right, so just a little reminder, for an or statement to be true, only one of the conditions must be true, and of course it's okay if both conditions are true. So that's about it for or statements in Python.